When you were in high school, they told you that one of the things that you had to be able to do when you were confronted by a chemical reaction was to be able to balance it. You needed to make sure that the coefficients that sat in that chemical reaction were such that you had these conservation laws managed. So for example, if I was to show you something like water, and I told you that it makes hydrogen and oxygen, as you take a look at this right here, you'll notice that there are two hydrogens on one side, two hydrogens on the other. You're happy, but there's one oxygen on one side, two on the other. This is not balanced in terms of mass. And so you had to come up with some way to learn how to balance it. The thing is, they never really gave you a good way to balance it other than to offer this sort of infamous statement that they called, well, balance it by inspection, which meant look at it and stick a bunch of stuff in a bunch of different places, and it'll work out after a while. The good news is that when you do balance by inspection and it works, you know it works. Why? Because if you add up the mass on the one side and compare it to the mass on the other, it always has to be equal. It always has to be balanced. So here you've got 4 hydrogens here, you've got 4 hydrogens there. You've got 2 oxygens here, you've got 2 oxygens there. This thing is known as mass balanced. The problem that arises is not only do you not always know whether to put the 2 here and here as opposed to a 1 here and a 7 there, but there's a new complexity built in here because I also have to do something called charge balance. To be charge balanced suggests that I need to make sure that whatever the charge is on the left side, it has to be equal to the charge on the right side. Well, this one's a pretty easy one to see because although we don't really think about charge balance, I've got no charge on the left side, everything's neutral, and I've got no charge on the right side, everything's neutral. So not only am I mass balanced because it's 4 and 4, 2 and 2, but it is charge balanced because it's 0 and 0. What I want to be able to show you is a way to balance redox reactions. When I balance redox reactions, I need to be able to say that they are mass and that they are charge balanced. And I need something better than this notion of balancing by inspection, because trust me, I can very quickly show you chemical compounds that I would like you to balance where it's going to be almost impossible for you to be able to balance them by inspection. For example, I'm going to show you compounds like permanganate, MnO4-, that I'm going to want to react, say, with some iron plus 2 to make some MnO2 and some iron plus 3. And I'm going to say to you, balance that. If you try to balance this sort of thing here by inspection, you're going to be here until sometime in February.